Well, we're going to have to wait a bit for people to show up. They're going to have to go into the wrong room and come here. So I'll wait till maybe 10 minutes. And while that's happening, we might as well look at the news. So Google has announced that they are going to do away with third-party cookies. And that's quite relevant to this class. That has been the main way you do targeted advertising. So you go to a site like CNN, and you only intended to do business with CNN, but third-party companies, DoubleClick invented this, and Google bought them, and Google's the king of it. They put links on the page that go to sites you did not want to see. And the links don't do anything except give them an excuse to put a cookie on your machine to track what you're doing. And that's why the internet is free, because they make a ton of money from these targeted ads. But it's now become very politically hostile to the security companies because of Cambridge Analytica and Steve Bannon, who took technology that was originally developed to stop people from being radicalized and becoming terrorists and turned it to the opposite goal of making people more radical to start a race war. And that was, so people have finally got fed up with that, and they're currently planning to censor the internet. Both the right and the left want to censor the internet to stop it. So Google wants to forestall that by putting on what they call industry self-regulation, hoping they can avoid having the government march in and follow the internet. So it'll be interesting to see what comes of it all. By the way, if you want to get rid of this stuff, the simplest way to do it is to use the Brave browser. That's what I'm using. The Brave browser blocks ads, and it has a cryptocurrency, so you can allow the ads in and get paid for viewing ads, some small amount of money. And that is the alternative model of the internet, where instead of everything being free, you have to pay something to use the internet, and then you don't have to invade everybody's privacy and put ads everywhere. Anyway, what's that? Yeah, but I don't think it's going to replace paid advertising. I think that ship has sailed. I think we're stuck with the privacy invasion, paying for everything. And anyway, we will see. Anyway, this is interesting. I'm waiting for this. They now have smart contact lenses. They demonstrated them at Consumer Electronics Show. They have prototype contact lenses that display things. So this is better than Google Glasses, not quite yet up to the Google Brain implant, which they've been talking about, but they don't yet have commercially available. But you know, it's a shame you have to carry around a laptop and a cell phone and everything. Why don't you just build it into your body like a cyborg? That's certainly where everybody wants to go. They have wearable computing is the rage. And you know, this is the latest version of it. So it's not yet for sale, but soon it will be, and we'll see how well it goes. So Google is now a $1 trillion company. There are now $4 trillion companies in America. I didn't know this. I guess I must be a communist, because the first thing I thought is, why do we have homeless people dying in the street? If we have that much money, I think, you know, might be about time for a socialist candidate. This is pretty outrageous that we have so much money for the rich and we don't even take care of our people. But anyway, I guess they're the $4 trillion company. I heard a while ago Apple was richer than the entire US government, briefly, and maybe they still are. And I would imagine, yeah. And Google is up there too, because of all that tracking. So there are a whole series of scary Windows patches. Some of these actually came from the NSA. See, the NSA is also got a public relations problem. The NSA develops exploits, and they don't tell anybody. They use them to hack into people and spy on people. And then they were sloppy with them. One of their contractors put their NSA exploits on a machine that had Kaspersky antivirus. So Kaspersky antivirus forwarded the NSA malware to Russia, where it went to the military, and then they dumped it publicly. And that led to the WannaCry worm, which shut down hospitals in Britain and almost in America. So people said the NSA is responsible for that, and you can argue that. But in any case, the NSA now has a public relations problem. They are perceived as a threat to the internet. So they have begun to warn manufacturers about security problems sometimes. And they also released their primary reverse engineering tool called Ghidra, which we're going to use in, I think, 128. We're going to be using Ghidra extensively because it's really awesome. It replaces about a $10,000 product, IDA Pro, the fancy version. It's very nice. And I think the NSA did these moves recently to try to polish up their public relations. So there's another one. There have been 2 RDP vulnerabilities. If you use remote desktop protocol, you can't use it on campus, by the way. It's blocked because it's too dangerous. Most companies should really knock it off. You shouldn't expose RDP to the internet. Microsoft designed it to be used that way, but it has never been safe enough. And there are a bunch of vulnerabilities and exploits that will just let people take over your machine without having a valid name and password. So what you need to do is put it behind a VPN, so that people have to first log in and prove they're an employee of the company before they can get to RDP. Anyway, so here's another one. And there's a second bug that just came out, which is up here someplace. Let's see if I can get this out of my way. Right, dum-de-dum, too many. There, this is the one. And this should be the Rickroll, yeah. This is a Microsoft flaw. When they validate SSL certificates based on elliptic curve cryptography, there are 4 numbers to specify the key, and Microsoft software only verifies 3 of the numbers. And what that means is you can easily create a fake certificate that the browser will accept as valid, even though it's not really the right public certificate, because it just has 3 numbers in common with the right public certificate. So here's an example of this. They made this browser believes it's going to nsa.gov and it's seeing Rick Astley. And this is not just a browser problem. This is a fundamental Windows cryptography problem. Any Windows 10 machine will be fooled by this, and that means updates from software, signed software, all these supposedly secure products that are signed with elliptic curve cryptography are vulnerable on Windows. So everyone should be rushing to update their Windows, or so they say. Now, for the last 2 years, since Windows 10 came out, everybody has learned to not put on updates, because Microsoft updates have been terrible and break everything. And almost the security experts I know have told people just leave your machines at least a year behind on their updates these days if you actually want anything to work. So it puts you in a kind of bind here. But anyway, they're right. A lot of people are saying you need to update for these security flaws right away if you're using Windows. Anyway, and there's a detailed analysis of that one in one of these. Yeah, this is the one explaining how it works in quite a bit of detail. But we go through this kind of stuff in the cryptography class, which we're not doing this semester. But the point is, you've got various parameters. This is RSA encryption, or GSA certificates. But the point is, you have these parameters, and if you don't verify all the parameters, you haven't proven that it really came from the right public key. And Microsoft skipped one. They did something similar in Internet Explorer 3. When you go to a certificate, like this thing probably has a certificate. Let me see if I can view the certificate. Looks like I can. Okay, here's what I wanted to show you. Here's the certificate chain of authority. So this certificate comes from Let's Encrypt, and Let's Encrypt is trusted because of somebody DST root. So your browser has built into it about 100 root certificates, which it trusts, and anybody who signs anything often goes through an intermediate step to the root. And so you have to take the certificate signing this page and verify that it really came from this authority, and take the one signing that authority and verify it really came from this one, and then verify that this one is the way it's supposed to be in your browser, and then you trust something. And what Microsoft did in, I think, Internet Explorer 3, one of the early versions, is they would just check the next step up and no higher. So you could make a fake certificate and another fake certificate to back it up, and they would fall for it. It just didn't walk all the way back up the tree. It's easy to make these flaws. These errors keep happening. One of the ones I'm finding in a ton of Android apps and iOS apps is that they don't verify certificates at all. They just believe any certificate. The reason these flaws happen all the time is that it seems fine. The product works fine when you go to the real website, and people don't test it by putting up fake websites. So they can just resist for a long period of time. There are many cryptography problems that are incredibly bad and persist for years, because when cryptography is broken, as long as it still works when you use it, there's no way to tell that it's broken. Anyway, so not unless you do a test, and many people can't be bothered or don't know how to do the test. So let's see, I'll do a couple more of these. Let's see, this guy is going to come give a guest lecture here in March. He is a high school student in Dublin, and he is involved in political campaigns quite a lot. And he does activism. And his form of activism is he hates CNN for some reason, and he humiliates CNN by releasing their results of polls and stuff 20 minutes before they're officially released, because they just use a predictable URL string. So he can guess where they're going to put it and see it before it becomes public. And he has told them, and they haven't quit doing it, and he is promoting activism in this way. And I'd like to talk to him because I've done a lot of that kind of activism. And anyway, so he'll come give a talk here. It's on my homepage. I think I've got it here already. In March, I think, but maybe it's not showing up yet. But anyway, he is coming in March, and I'll have it up there. If it's not up there yet, it will be pretty soon. Anyway, All right. So it's about a quarter after. I think probably people have found the class by now, I hope. I moved it to this room because YCAN correctly pointed out to me this room is better because we have the machines we know, we have the danger zone and stuff. So I ought to move things here. It turns out this room is not used except on Wednesday night. So I'm moving a lot of my classes here. All right. So this class is 129S. This is securing web applications. And we are going to go through this book. This book is one of the most important books in information security. It is extremely famous. The NCC group is hiring students to be real pen testers. And what they said is they needed to go through this book to prepare them for a job as web pen testers. And that's why I started teaching this class. Industry experts said, this is really important. You should teach this material. So that's what we're doing. This book is written by the author, Burp. Almost all the projects use Burp. Burp is the hacker's proxy that lets you sit in the middle between your browser and the web, and you can see all the requests and all the responses, and you can modify them. And that's how you find vulnerabilities in websites and flaws and patch them. So mostly we're going to be doing that. All right, so we'll go through the details of the web. For grading, there's quizzes and there's homework. The homework all comes in by email. You'll be taking screenshots and emailing them in and getting points. And the quizzes are online. They're in a Canvas server, but they're not the City College Canvas server. You have to click this link and sign up to my Canvas server. I'm using one that is off the City College website because I let everybody in my class, even if they're not officially a student, even if people in other countries and stuff. And of course, the official CCSF server won't let me do that. Now, if they actually were organized around here, they wouldn't let me do this, but they're not, so they do. So I exploit their chaos. All right, so anyway, our whole security program is here because of that chaos. Any other teachers could not teach hacking because they had functional administration to say no, but we had no administration for a while, so I just started teaching hacking, and there was nobody to say no. And then by the time they hired chancellors and stuff, they figured, well, I guess it's okay, it's already happening. So you have to watch for windows of vulnerability and exploit them. Anyway, so there's a grading sheet here, and I even have it on paper if anybody wants it on paper. I didn't print very many copies because this is not very popular these days, but it's there if you want it. But all this tells you is how the grading works. And so there's a textbook. Whoa, that's not right. All right, there's a textbook, and there's homework and quizzes and a final exam. All the quizzes and the final exam are online, and all the homework comes in by email. And then if you get 90% of the points, it's an A, and 80% it's a B, and so on. And you can get extra credit by doing extra projects. There's a portion of many of the projects that's extra credit, and you can do things that I did not assign and get extra credit for it. For example, you can hack me. If you hack my website or any of my stuff, then you will get extra credit, and you will be commemorated on the Hall of Fame of people who've done that. Here's the people that hacked me. This was one of the first ones. He snuck up behind me in the lab and recorded my password with his cell phone without me noticing it. That's a good one. I don't know much of a defense from it. AxiomX found root on my server and put banners on there to prove he had it. I thought that was a secure server, and it wasn't. I learned something. And there are other ones here. AnonSec hacked me. Palestine Anonymous hacked me and put a message on one of my web pages. So if you do that, I will not prosecute, and you will end up on the Hall of Fame. There are some restrictions to that. I have a disclosure policy here, which everybody should have, which, oops, there. And the point is, there are certain rules. You can only hack my stuff, not the college. I'm not authorized to allow you to hack the college. In my opinion, the college should have a similar policy, but unfortunately, I don't have the authority to make it happen. And you have to do some reasonable things, like try not to ruin things for other students and give me time to fix it and stuff. But if you do those things, I have a legal agreement here that I will not prosecute you. So anyway.
As long as you don't break anything.
Well, you might break something by accident, but you have to make a reasonable effort not to break anything.
Okay.
God, nobody's perfect. Yeah. Anyway, and this is what most modern companies do. The wisest ones do this. It turns out that if you protect yourself with the full power of the law, you actually make yourself less safe, because now all the white hats that would like to tell you about your problems don't dare to tell you. The black hats are coming in anyway, but it's difficult to explain this to corporate management. It's a lot easier lately because the US Department of Defense is now on their second or third bug bounty series. So that's beginning to thaw the ice, and people are beginning to realize that you're safer by not using the law to protect you in the simplest, most obvious way. But anyway, all right. So there is a job fair coming up on Monday the 27th. If you want a job, you should come to this thing. A lot of people get jobs there. We had more than 100 students at the last one, and I think 13 employers hiring for at least 50 positions. A lot of students got jobs on the spot. Bring your resume, dress up, show up at that thing if you like. And if you don't think you're ready for a job, you might show up just to listen to people and see what they want. We have a lot of employers at all different levels. Some of them have volunteer internships with no money, where you do something like recycle broken computers. Others have highly paid professional jobs as pen testers or developers, or other kinds of security jobs and coding jobs. So it's a good idea to go there if you're interested in getting a job, which I assume most of you probably are. This is pretty much vocational training around here. All right. So if you want to add, you can just add. You make a request in there. I think it'll just let you in because the class is not full yet. If it fills up, it just comes to me and I will approve it. There's no problem with people being here. You do not have to physically come to class. This is a big thing. You can tune in online. We have 7 students doing that right now. You can just go here and connect with Zoom, and then you can participate remotely. And also after the class, I put the lectures on YouTube, and you can just watch them on YouTube later if you want to. So you do not need to physically come here unless you want to make friends with the students and join the cyber competition team or get involved in other projects and stuff. But so there's always some people that do that, and that's a way to be more involved in what we're doing here. We have a very powerful cyber competition team, and that is training on Saturday with Elizabeth, who's the coach. So if you're interested, you should definitely come on Saturday and talk to her. She's teaching from 1 to 4 in this room on Saturday. She's teaching 140, which is preparing for the cyber competitions. We have a defense competition and an attack competition, and our teams are very good in both cases. And that really gets you noticed by a lot of people. It gets your jobs. It's very good. So I highly encourage you to check that out. We always need new people on the team because the people on the team keep getting jobs and leaving. It's kind of the point. Anyway, so all right. So are there any questions about anything? Yeah.
I'm being told that I can't connect securely to the page because of the Trojan.
There's a Trojan on my page?
It's samclass.info.
Yes.
Sam's class, S-A-M-S.
Sam's class.
Did you remember this S?
S-A-M-S-C-L-A-S-S.
Yes. Do you have malware bytes?
Yes.
Yes. Malware bytes keeps doing this. There is an amateur in Romania who flags my page as malicious, and every couple of weeks they take it down, and then this guy flags it again. This is they can't tell the difference between instructions to hack and actual exploits. So yeah, that's an interesting fact. Yeah, some people get upset about this when I go teach at corporate places. So there's not a Trojan on my page, but there is a bunch of code on my page that is related to viruses and stuff.
I've been there before. This is the first time.
It happens over and over. They keep flagging it as malicious, and then after a couple of weeks, they'll figure it out and turn it down, and then it'll get flagged again.
Is there a simple way to get rid of it?
I don't know. There must be some way to override it in your device. Yeah.
Are you using malware bytes? I had the same issue. I tried different ways to try to figure it out, but I couldn't. But I'll try it again. Later.
Yeah. Many of them have a way to make an exception. It's an interesting issue.
You can add it as an exception in the list.
Yeah. There should be some way to whitelist. Yeah. Burp what? Yeah. Remember, most of it was Burp. Burp. This is a Burp Suite. Yeah. Burp Suite is the main tool you use here. And the point of this is it's a proxy, and you can send all your traffic through here, and it will let you see all the requests and responses that build a web page. And we'll be doing a lot of things with that. This is the main tool dependent of web application security testers. All right. Good. Any other questions? Well, let me go down to the stuff in the book. We'll start with the first chapter here, which I've got 129 as lecture. There we go. All right. All right, so let's start with a bit of this stuff. All right, so as you know, the whole world is web applications now. There was a time long ago when web pages just sat there, like in 2002. You'd just go to a page, it would just have text and images, and everybody would see the same page. It would just sit there. Like my page is an example of really old-fashioned web pages from the dawn of the web. This is almost nobody does this anymore. They all have dynamic content like Amazon. If you go to Amazon, everybody sees a different page. It reads your history. If you've logged in, it knows who you are, and it customizes the page for every user. It changes the price, it changes the content. It's a dynamically generated page based on a template, and engines building it. And unfortunately, it's very complicated. There are something like 10 or 20 servers working together to create that content. And unfortunately, they are all running different languages. So it's basically what you've got is something that was created by a whole bunch of systems talking to each other and changing the language everywhere. So it's chaos, and that's where most of the security problems happen. One server sends a message to another server, which is doing something different and misunderstands it. That's the most common way you get security problems. So it's the old-fashioned static website where you're just looking at static things, like I could have printed it on paper and mailed it to you and it'd be the same thing. These things are relatively safe because you do not get any opportunity to put up data at all. You can't even put in a name and a password or do any shopping or anything. So you might be able to exploit the server operating system itself, but you can't do much of modern web attacks on this sort of thing. But almost nobody has web pages like that anymore. They have things like Wikipedia and Amazon, where not only are people sending up cookies and it's watching your geographical location and other things to customize the page, but you can put content on it like Facebook and Twitter. So it will take data from you and put it on the page and then show it to other people. And that is really dangerous. Now I'm putting data on my page that came from random people all over the web. So if I make a mistake and let them put up something dangerous, it goes to everybody else. And that's the web we're living in. So you got shopping and auctions and gambling and everything up there. And all these things involve people sending up confidential data like credit card numbers and passwords, and it being processed by a bunch of servers and data going back to other people. And that's how we get the modern world where everybody gets hacked like crazy, and there keep being mistakes where you go to email and you see somebody else's email and so on. It's a very complex system. And it evolved from technology that was designed for a much simpler situation to just deliver static pages. And it is not cleaned up and organized in a way to make it secure. It's really very chaotic and confused. So then you have all the internal applications. People at companies are now managing their internal applications like payroll and HR and enterprise resource planning, all locally with things like SharePoint portal. Your internal documents that your employees are using to see company resources are also these complicated systems like Outlook, Web Access, and so on. They're very important and very helpful, but they have the same large number of security problems because, again, it's a complicated bunch of servers working together, making mistakes as they send data from one server to another. So HTTP was not designed for any of this. HTTP was designed for the original internet where you would request a page and you'd get a page. It was not much different than FTP file transfer. You'd ask for a page and it would just send you that one file and you look at it. That was all it was designed for. But that didn't let you have personalized data like email, so they bolted on extra things like cookies and sessions imperfectly. So now there are clumsy, half-baked techniques of trying to remember who you are. So I know whether you've logged in and I know who you are and I know to show you your email and not somebody else's email. And it turns out that there's not a standard way to do that. There's about 20 ways to do it. None of them work very well, and people often implement them wrong. So servers often make mistakes remembering who you are, and that leads to a lot of vulnerabilities. So breaches are common, and attackers can often take down web pages, steal the database, and so on. So you'll see people say this site is secure because it has an HTTPS certificate. And that is more secure than not having HTTPS, but it doesn't make you entirely secure at all. All it means is that the data is encrypted and you have verified the identity of the server. Now, as we just talked about in the news earlier, there are often errors in the operating systems or the browsers, so that in fact, even those guarantees are not accurate. Right now, you can go to a page that Microsoft systems will tell you is secure when it's totally the wrong server. But usually they patch those in a hurry. So under normal circumstances, when you actually get an HTTPS URL and this message here, like a padlock or green, that really means to a high degree of confidence that you know who is running the server at the other end. So you're really talking to Amazon and not somebody else. But that doesn't mean you're secure. It just means people can't just steal the data in transit off the wireless network. You can still have a bunch of attacks at the other end regardless. And whenever you see anybody claim to be 100% secure, like these guys with their blockchain voting, they're idiots. There's no such thing as 100% security. Nobody, no professional will ever say that. There is no such thing as 100% uptime or 100% security. That's stupid. Of course, the power could go out, the cables could break, you know, there's obviously something that could go wrong. You can have more secure and less secure systems, but there's nothing you can build or buy that will ever give you 100% security. Yeah.
Yeah, there are some website they have HTTPS,
Mhm.
but there's some page they don't have it. Only some pages have it.
Yes.
It's very confusing.
Oh, it is. And even if it's all HTTPS, there are a bunch of attacks that attack the server by sending messages to the server like SQL injection, which then have an unexpected result. And the encryption doesn't stop it. You're still sending data to the server, which it can process. So not all attacks require unencrypted protocols. It's just the case that if you aren't even encrypted, then you have another attack where people can just view and modify your traffic on the way in or out. So I mean, HTTPS is more secure than HTTP, but it's not 100% secure by any means.
Why did they do that? Why did they like put part of the website?
Oh, well, there's actually a good reason for that. I had an argument with Dan Kaminsky, one of the famous guys on the internet, about it a few years ago because Amazon was moving to HTTPS. And I was picking on Amazon because they had a bunch of HTTP cookies. And I said, they should just put everything HTTPS like Google. And Dan Kaminsky said, no, that's too much work. And I was surprised. But I looked into it and he's absolutely right. The problem is, if I do it on my page, I can do it because there's just me. I can deliver. But if I'm Amazon, I have business partners and advertisers and third-party people selling products. So I can't upgrade to HTTPS until all of them do. So if you sell advertising, you would lose a bunch of your advertisers where you said you must upgrade to HTTPS or you can't put content on my site anymore. So for business reasons, and it's all true of people with legacy systems, this is always the problem. The reason you don't jump to the latest, most secure version of anything is because you have legacy stuff that's still running the old insecure version. And you don't want to pay to replace all that right away. So this is why people have old content mixed with new content. Yeah.
Do they wait for it to break or something? Usually?
Well, in practice, you make a decision. For example, companies that have Microsoft domains, almost all the big companies do, whenever you make a domain controller, it will tell you, do you want a native domain controller? Like you've gone up to Server 2016. If you make a native domain controller, this is by far the most secure, but then all the domain controllers have to be running Server 2016 or later. If you have older servers running Server 2012 and Server 2000, then you have to make a backward compatible domain controller, which is much less secure because it can talk the older, weaker protocols. So you're a company with locations all over the world and thousands of servers, and you decide to either upgrade them all at once or to make the less secure version that lets you keep using your legacy stuff. So, and it's a business decision. So you'll decide how important security is to you and how much it's going to cost and how much time it's going to take to update all the stuff. And if you're a company taking advertising data from people, then you might announce in 4 years, you're going to have to update your stuff to HTTPS, give them some time. And then there'll come a time when, say, 90% of the people have done it, and now you feel like you can afford to write off the rest. It's just a business decision. Yeah. But you can't just do it on a dime by changing your server. In the real business world, you have to be compatible with other people. Anyway, so here's what the textbook authors found. Cross-site request forgery is where you can send data to a page which is misunderstood as coming from a different page. This is a very common one. One simple version of this is where I steal a cookie from you and I use it to log into your account. This works on almost every web service. There's no good reason for it. It would be easy enough to mark that cookie so it would only work from one machine, but almost nobody bothers. I went through a list of sites you can do this for. Well, many sites leak pages. SQL injection used to be the most dangerous exploit on the web. Until about 2 years ago, 99% of all stolen data came from SQL injection. It's incredibly dangerous and incredibly easy. We'll do quite a bit of it in the projects. I don't think it's any more the #1 flaw because there's an even worse one. Amazon managed to come up with something even worse. Now there's open E2C buckets, which means you just put your data on the cloud and everybody can just take it. And every week I see another 500 million records exposed by Amazon. I think they've managed to outdo SQL injection. I haven't seen a mathematical study of this, but my impression is that Amazon has single-handedly managed to make something even less secure than SQL injection. But anyway, it's incredible how much data gets stolen.
What was that called?
Open Amazon buckets. EC2, Elastic Cloud Computing, is Amazon's most lucrative product. You can put your stuff on Amazon servers and you can put your data in Amazon databases, but the default setting until I think 2 months ago was no security. And it was up to you to realize that and turn it on. And many people did not realize that and did not turn it on. By the way, Microsoft did the same thing. SQL Server, before I think 2005, by default, everybody would have an SA administrator account with no password at all. So people, if they just click next, 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 and put it up, which is what a lot of people do, then anybody can just log in and steal the data. That's why everybody learned to stop doing that. You should not have any kind of default. You should force people to choose a password while they're clicking next, next, next. That would make it a whole lot better, because some poor guy, which could have been me when I was working in the financial industry, that says, you got to have this running by 5 and it's 3 o'clock. And I'm like, I've never heard of it before. Next, 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 next. That's the way we'll fix it later. And of course, tomorrow there's another disaster and later never comes. You know, that's the way business is. You shouldn't make products that have an insecure option. But most people do until they wise up. Like Mongo. Mongo tells you in the documentation, do not connect it to the internet at all. Mongo is fantastically insecure. It does not even have provision for security. You should only use it locally. There are thousands of Mongo databases connected to the internet. You can find them with scanners. People don't read the documents and they just put it there. Making products insecure by default is just kiss of death in practice. But a lot of people do it. So here's, for example, an attack that let people do an unauthenticated request, and then they could get information from users. This is very common, and I've found a lot of these myself in Amazon and Android apps and iOS apps, where you can send a request to a server and find out information about another user which you're not authorized to have. So you send a request up without logging in as administrator, and then you get a whole database down. I was showing one last night in the mobile device hacking. There was a college, University of Houston, had the same thing. You could search for a user and you get information about all these other users without logging in as the administrator. It's a quite common flaw. Anyway, so here's the OWASP top 10 lists. I think this is not the latest version of it, but it's fine. And we'll spend most of the class going through these things, really. So weak server-side controls are what I described, where the server doesn't really prevent you from doing things until you've logged in appropriately first. But certain methods are available to people they shouldn't be. You store data insecurely, say without encryption or in the wrong location. You don't encrypt it properly in transit. You leak data that shouldn't be coming out. Like if you go to a web page and you mistype a URL, you'll often see a big error message and a bunch of source code telling you a lot of information about the website, and that should not happen. You should not expose the contents of the website to anybody. That's unintended data leakage. And we mentioned poor authorization and authentication, where people log in, but it doesn't correctly keep track of who you are, and it doesn't really restrict access to everything to make sure you've logged in correctly first, so people can get to things they shouldn't really get to. Many ways you can break cryptography. I've seen people use ridiculous, unsafe cryptographic techniques like hiding a private AES key on a phone where it can be found, or using the Caesar cipher instead of a proper modern cipher. And then there's injection, and these other ones that we'll talk about. This is the mobile device risks, and there's another one for web apps. We'll be going through these in quite a bit of detail. You'll be doing quite a few of them in the projects. So I did a lot of Android apps, and I found, for example, almost every major company, their Android app is vulnerable to modification. I can download the Bank of America app, and I can put malware in it and redistribute the modified app. And when people run it, they can actually go to the Bank of America and do banking, but their data is being stolen on the side. We'll do that in the 128 class, and that is insane. They could easily prevent that. The NFL does not allow that. You could easily put a modification detection in your app that doesn't let people run a modified app, but they just don't bother. It is amazing. Yeah.
Those apps you tested, is it still vulnerable?
Oh, yes.
Even Chase?
Oh, sure. Sure. We'll be using, Chase got worse after I warned them. Or no, Chase, I think, actually fixed this one. I will try Chase. They keep changing them, but nobody cares about code modification. The only people that care about code modification are games, because other games will steal their code. So they actually like to encrypt the code or something, but banks and companies don't seem to care. And I went through a lot of colleges to see what was going on. I found a bunch of colleges infected with Viagra, selling illegal drugs from campus. I found a bunch of colleges that would expose student records or staff records just open to the web. And I found a bunch of SQL injections, and I mostly found that I could not notify anybody that would care. There's usually nobody involved. And the thing I've learned here is something, there was a research study that just came out last month that said something which I observed in practice, is the major predictor of poor security is not the version of software the major predictor of poor security is a big, sprawling organization that's not well organized, where people don't really know who the boss is or who should check things or who I should tell about this problem. That is what makes things insecure, is people that aren't really working together, that don't really have a clear chain of command and a proper process of tests and reviews. If you're just sort of disorganized, that is the worst thing for security. And that's what I found. And colleges are, of course, famous for this. You have a bunch of crazy professors doing stuff. They don't even tell people. The poor people running the network don't even know what's going on. Nobody knows who the boss is. Nobody has any money. People are just buying servers and sticking them on the network and putting stuff on them and then forgetting about them for 5 years. You know, no wonder it's all full of mistakes. And a lot of companies are the same way. It's just sort of sprawling and chaotic. So you make some ridiculous mistake and nobody really checks for it or catches it quickly. So the fundamental problem here is that users can send up data, tons of data. Every time you make a web request, it sends a whole bunch of data up to the server. And the developers don't know that that stuff could be malicious, and they don't think about it. So you can modify that data, and attackers have tools like burp. So if you make a form, I can give you like a password field that only has 8 characters. So I might believe that the password will always only be 8 characters long, but I control my machine. I can escape the web browser and make that 1,000 characters long outside the browser. So the developer cannot assume that it's only going to be 8 characters long just because the form they gave you limited it to 8. And a lot of them don't understand that. They don't understand that you have to harden your systems against any kind of malicious input. You can't just make the portals you give the user protected. You can't trust anything that happens on the client. And this is one of the most common problems. They put some kind of security decision on the client instead of on the server. And they think that they can trust the client to not alter the data, but of course you can't. Anyway, so for example, we'll do this. There are a lot of websites where you shop and they put the price in your browser, and when you buy it, you send the price to the server, and it believes the price that came from you, not the price that came from the server. So you can modify the price and buy the item cheaper. And you can modify a session token, be it somebody else. And SQL injection is the main one, which we'll do in the projects, where you send unexpected input, and now you can execute commands on the server and see data from the database without being authorized to do that. So the fundamental problem is that people are designing websites, and they've taken coding classes like you can take here. They've learned how to make beautiful web pages in PHP scripts, and their main concern is to make it beautiful and make it fast and make it reliable so it doesn't crash, but they don't really know how to make it secure. They typically, that's too much for them to study. They're busy doing other things like making it fast and efficient, and they think it's up to somebody else to make it secure. And so you have a development team making products that are unsafe, and you have another group of people, a security team, trying to patch up the holes. It would be nice to imagine that you could somehow mix the two properly and have security in right from the beginning, but very few people are organized enough to do that. That's DevSecOps, and some people are getting into it, but many people still have the old system where you deploy code, and then when people complain, you try to patch it later. And there's a statement I've seen, they say, patching something at quality control after development costs 10 times as much as writing it secure in the first place, and patching it after it gets to the user with an update costs 100 times as much. So it really would be better to be organized and do security tests early in the cycle, but very few people are organized enough to do that. The fundamental problem here is organization. Anyway, so you've got perimeter defenses like firewalls and bastion hosts and such to try to keep people out of critical systems, but they don't really make you safe anymore. This is what we all learned in 2010 when China hacked Google. They were living on the Google servers, stealing all their stuff, and 30 other major American companies, and they have been since about 2005. The Chinese have been continuously having permanent malware inside American companies, stealing all this stuff, and our defenses totally did not stop them. And now there's 40 or more known advanced persistent threat groups doing this to everybody. You can no longer trust your defenses to keep the bad guys out. Instead, you have to have layers of defenses. You have to have firewalls and antivirus and intrusion detection systems. And then you have to accept that some people will get in anyway. So you have to have network monitoring and detection and incident response, because you know that all those defenses don't keep all the bad guys out. So you have to have another response when you find a bad guy that's gotten in your network, and you just have to constantly battle them and keep them out. you can't imagine that your network is clean. They call this a zero trust network. Don't trust your servers, don't trust your laptops. Realize that all those things could be infected at any time and plan for that. One of the kings of this, by the way, is Netflix. Netflix has one of the most secure companies in the world. And what Netflix uses is the Chaos Monkey. One of their developers came and talked to us about it. Netflix tells everybody, plan for things being broken or under hostile control at any time. So if you have a server doing something, you have to have a backup server. And they wanted to make sure people did that. So they have a thing called the Chaos Monkey that randomly breaks things deliberately. It corrupts network traffic, it breaks network connections, it takes servers down at random just to make sure everybody remembers this. So they break things deliberately themselves to make sure everybody learns, don't have something that can be broken. Everything has to have a backup and another backup so that when this one fails, the other one will take over. That's the way you do it. At first, this sounds insane. You're deliberately breaking your stuff. It's just like my vulnerability disclosure policy. I'm telling people to go ahead and hack me. How can that be good? In fact, that is good. And deliberately breaking your own stuff is good. I know Matthew Prince, the CEO of Cloudflare, and he told me Cloudflare is a distribution network that's global. They have about 30 or 40 data centers all over the world, and they're distributing a large portion, like 10% or more of the entire internet. And it's very fault tolerant. And he says, I go into the San Jose data center and I pull out the cable to take the whole thing offline. And we measure, and if you're pinging a server, you only lose one ping. I make sure that we can have a failure of an entire location and everything keeps running. And that's what you do when you're really serious about being fault tolerant. Anyway, all right, so you can attack the users. Users can attack each other by putting up malicious things like cross-site scripting. And another common thing is password recovery is a huge problem. If you have a lot of users, they're going to forget their password, and you can't, unless you are like the military or something, you can't really make them drive to your location and bring a photo ID to get their password reset. Instead, you have some automated system where they answer a question like, what town did you meet your spouse in or something? And then they get a password reset. And that turns out to be really easy to fake. So that's usually the most wide open hole because you aren't willing to be irritating and spend the money for a secure password reset system. So anybody can pretty much just guess the answer to your password reset question and get in. That's another big problem. In general, many products that have been around for a while have gotten much more secure, like WordPress used to be terrible and it's getting better and better. Microsoft Windows used to be terrible and now it's much better. Mature companies do get more and more mature usually, more secure, but there's an endless chain of upstart companies that are jumping up with a new product that of course is typically insecure, the most extreme example being the Internet of Things. Now you've got smart televisions and smart watches and smart shoes, and you're going to have an internet connected contact lens in your eye. And those things are just rushed to market to make them as cheap as possible and as fast as possible. And they usually didn't think about security at all until later. So you got these Nest doorbells and people are taking them over and taking pictures of your family and stuff. You know, it's the natural thing. The market rewards you for having the product out fast and cheap and impressing everybody, and they don't notice the security problems until later. So it's a fundamental conflict. The way to make money is not equal to the way to make the best product in most cases. Anyway, so I got some cahoots about that. And it's 6:47. I think I'll probably stop there and not do the second chapter today because I'll put everybody to sleep. But let's do the cahoots for this. This is, we're going to do this every week. You get extra credit if you get the most of these right. So this is a web system. There's the ones, there's my cahoots. So there will be an option here. That looks good. So I run this, and you need to have a phone or a computer or something to do this, and people remotely can do it. Go to kahoot.it and type in that number, and then you can join and compete. And you get extra credit if you're one of the 3 high scorers on the Kahoots. I have a couple of these every lecture. If you watch live over Zoom, you can do this. If you watch the YouTube video later, you cannot win this contest anymore, of course, but that's why it's just extra credit. And it's not required. I find that most students enjoy this, but there's always a few students that do not enjoy it and prefer not to do it, which is fine. And then there's one student, my most dangerous hacker, who hacked the Kahoots. That was pretty awesome. She wrote a script that made like 1,000 identities, and now it would guess the right answer. She would always win every one. It was pretty good. It's not subtle, but it works. I learned this from Cyber Patriot, which is the Air Force training for high school students. And we do it here now. It is very good. It's really fun. They teach those high school students serious security, securing domain controllers and Linux boxes and Cisco. We teach it here every summer. It's really popular. I highly recommend it. And I learned a lot about teaching. They have to make it fun for the high school students, which is my goal too. And they have a lot of cute things like this.
Is that thing for high school only?
That exact one is, but you could be a trainer or an assistant. But yeah, you can only take it if you're a high school student, but it's very nice. You know, we have the same content here in a sort of more formal way, like the Cisco Academy and stuff. But I was impressed at how good it was, how much fun and how advanced it was. It's also only defense, of course. Teaching attacks to high school students would get everybody in trouble, so nobody does that. But they teach you how to defend systems. Anyway, defense, by the way, is hard to make fun. It tends to be kind of boring. They managed to make it pretty fun. They made it like Cisco's packet tracer. If you've taken Cisco, you have a Windows server with like 20 problems, and you have to fix them. And there's a little counter showing how many points you have as you fix them. You're hunting for stuff on it like malware and firewall misconfigurations and domain controller misconfigurations, and you get points as you find them. It's really pretty fun. All right. Looks like people are still coming in. I'll give it a few more seconds. See if we get any more. I guess that's it. Oh, nope, here they come. Okay. Yeah. I'll give it 5 more seconds. 3, 4, 5. Okay, we're going with these people. All right. What's the most common vulnerability of websites?
Words come up here.
Yeah, you have to choose. All you'll see is like a colored dot, and you choose the answer that matches here. What's that? Well, you have to enter on your device. And by the way, you're rated both for accuracy and for speed. And there's 1,000 points for each question. So the answer is cross-site scripting. Something like 80% of websites have it. These other ones are less common. And yeah, that's why, it takes a little while to get used to this thing. Anyway, so what makes Web 2 earlier than the original web, different from the original web? Yeah, that's it. Users are now putting content up, which is very different. Now you have to have a login and all that jazz. All right. What's the most important defense method? This is a very interesting question. If you ask, they tried asking this question, normal consumers, they will tell you it's antivirus. They really trust their antivirus. The further you go in security, the more you don't trust antivirus at all. Antivirus sounds good. In practice, it doesn't stop much at all. The latest test I heard about a year ago is it stops 2% of the attacks. You think it's saving you, it's a lot of stuff sails right through it. It's really easy to sneak stuff past antivirus. I do it all the time. Anyway, updates are your strongest defense. The most dangerous thing is some vulnerability that came out recently, and there's a new attack tool. Professionals make updates as the #1. Amateurs make antivirus #1. Anyway, all right. What does SSL stop? There you go. Most people got it right. The point of HTTPS which is called SSL, although now it's the later version TLS, is that your data is encrypted and you know who you're talking to, so nobody in the middle can read or modify the data. That's what it does. Now, that doesn't stop these other attacks, which involve sending data to the server, which is then improperly handled at the other end. But it does stop attacks that would intercept data between you and the server, which is all it does. That's a useful thing, but that's not 100% security. It just stops certain attacks. All right. So there we are, and I guess we get to see who won. There we are. Kirk Cater, ah, yes. Yeah, I don't see Kirk. I said Kirk could just stay home because of the rain, he said. There's a student who's frequently here called Kirk. Anyway, he hates these things, so other people imitate him or something. Anyway, so I'll record the winners. The glorious Kahoot winners are here. By the way, if you use a fake name, these look like real names, so that's good. Sometimes people put up fake names like Kirk Cater is not going to get their points unless they come out of the closet and tell me who they are. Peter Chi, is it you?
What, Kirk Hater?
Yeah.
No, I wouldn't do Kirk dirty like that.
Okay.
I was
okay.
I was no more well, I take that back. I said I was no more Emmys.
Okay.
That was me. I was a
okay. So
else.
129S Kahoots. And today is 116, 16, 2020. Good. I'm just going to save this someplace. I'll email it to my grader.
Hate's a strong word.
All right. Anyway, so these two people, those look like real names, and you'll get 3 points for winning. Kirk Hader will only get points if they come out of the closet and tell me who they are. But anyway, all right. So what you should do, I don't think I'll carry on anymore tonight because I put people to sleep. Let me just tell you, get the book. If you haven't got it, start reading the book. It is a little dense and hard to read, but it is the Bible. By the way, I tell you, this book is kind of old, but people have told me every time I find a new attack, I go back and it was in here. This guy thought of everything. So it's quite, anyway, so start reading it. There's an online quiz you should take. You can still take them up to a later date and they won't lose points for being late, but you should start doing them as soon as you can. And you should start doing the quizzes and you should start doing the projects. There are hands-on projects here and down here they are. So let me just demonstrate a bit about the first project here because this is the simplest attack. We have an injection, SQL injection, introduction to BERT, and then you start making Google Cloud servers, and I'm going to add a few more here. So there's a lot of hands-on projects. So let me just demonstrate quickly the first one. This is one of the simplest web vulnerabilities, is a command injection. So you should need to know a little bit of MS-DOS, or this one's running bash. So if you don't know any bash, you'll learn a few commands here like date and ls and pwd. And I'll just demonstrate it live. So first you practice learning some bash commands. If you've taken any, use the Linux command line, you'll know it. If not, you can review a bit here. Let me just, I'll demonstrate a little bit of it here, terminal. On a Mac, you've got a terminal right here. So I'm just gonna make a new one that's not all full of Android exploits. What's going on there? All right, so this is now ZSH, wow. Well, let's make it bash. Okay, now it's, I think it's bash. All right, so now in Linux, if I do ls, I see all the files in my directory. So I'm gonna make a directory called demo. All right, I'll make a directory called demo2. All right, I'm gonna change directory into demo2. And now if I do an ls, there's nothing in there because it's empty. Now, if I do an ls -a, I'll see the hidden files, and every directory has two hidden files, dot and dot dot. Dot points to the current directory, and dot dot points to the parent directory above it. And now I can, so I can put a file, I can echo A. That just prints an A on the screen. I can take the A and output it to a file called foo. This greater than sign will take whatever was going to go to the screen and put it in a file. So when I do that, now I have a file called foo. If I do an ls -l, I see information about that file. That file is 1 byte long, and here's the date and time it was created, and there's the name, and here's the person that owns it, and here's the permissions. I'm the owner. I can read and write it, but not execute it because it's not an executable program file. People in the same group as me can read it, but not write to it. And everybody else can read it, but not write to it. Those are the security permissions in Linux. Anyway, so those are a few simple commands. And the interesting thing here is this ping form. So here is this is a page. If you have a router at home, you go to your router configuration page, there is usually a network test page where you can test to see if the network is working. And a lot of those are written badly. And this is an online version of the same thing. So it's intended to let you ping something. So you can ping, for example, the loopback address, 127.0.0.1. So if you do that, it does pings and then shows you the result. So it's going to take supposedly 4 seconds. Okay, so here it is. 64 bytes came from there and 64 bytes came from there. So it did 2 pings. Now, if you use the bash command line, and if I ping 127.0.0.1, this is what I get. I get exactly that, 64 bytes. So what's going on here is the programmer, who would be me, didn't know how to write a ping in PHP. So instead of figuring out how to write a ping in PHP, which is the language this is written in, they just made a line of bash that had ping and then followed it by an address that came from the user. So it used one language to make a line of code, which was then executed in a different language. And that's just done all over the internet, and it's incredibly dangerous. And here's why it's dangerous. Since the first language, the first PHP thinks it's getting an IP address, but I did not check to make sure it was really an IP address that went in there. I could put in something else. So if I put in like Fred here and send pings, it's going to pass it and not getting a reply. It's getting an error message, which doesn't come back. But if I carefully craft something malicious, like 127.0.0.1 semicolon LS, then it runs the pings, and then it gives me a list of all the files on the server. This is because if you have a command line, you can do more than one command. I can do an ls, and I can do an ls and then a ping. And then like, who am I? And as long as I separate these things by semicolons, I can just put multiple commands on the same line. It did the ls, it did the ping, and the ping's going to go on forever, so it's not going to get to the who am I. But the point is, you're allowed to put multiple commands on a line. And since my PHP just creates a line of bash, I can now execute any code I want on the server by just putting it here after a semicolon. Now, I can't do just anything, because if I do who am I, you'll see I am www data, which is the Apache user, and that is not an administrator. I'm not root. So I could not delete everything on the server or reboot the server, but I can read and write the web pages. I can deface the website. You can do certain things here. Anyway, so now you have the ability to execute some control on the server. So you have to put your name in this winners file, and that's your challenge here. So that's a ping injection challenge to get you started. And after that, we'll do several more projects in the same spirit. Let me get to the right class, though. The right class is 129S. So when you get it right, then you send in a screenshot to prove that you got it. And then there's SQL injection, which we'll talk about next time. SQL injection is also a command injection, but you have to write a different language. Instead of writing bash, you're writing SQL, which is at first an unfamiliar language to people who have never been a database engineer, but you have to get a little bit used to it. And then again, you can take over a server and do things you should not be allowed to do. And the most common thing you do with SQL injection is steal the data from the database. But you can do other things like deface the web server and put up malware and such. So are there any questions about anything? You folks should start doing that stuff. I'll stick around here for a while if anybody wants to work here. I generally stick around after class in this lab to help people who might want help. And I guess that's it. I'll be back here next week. The class will move here permanently. We're not going to go to the cloud hall anymore.
So all the classes are in this room now?
Yeah.
Except
This
for
one.
Wednesday.
Except for Wednesday and Saturday. I had to move those elsewhere. Yeah, good. All right, I'm going to stop the